Hello and welcome to PyData Global 2021. My name is Natalie and I'm very happy to be here and to be your host for this session. I would like to now welcome Jacqueline Nolis and Chase Ginther to our session, and they will talk about enterprise machine learning pipelines with unstructured image data. Dr. Nolis has over 15 years of experience in managing data science teams and projects at companies ranging from DSW to Airbnb. She currently is the head of data science at Saturn Cloud, where she helps design products for data scientists. Chase Ginther has also spent his career working on a wide variety of machine learning projects and is particularly passionate about ML ops and ML platforms. Prior to joining Snowflake, he was the engineering manager leading Deloitte's AI Center of Excellence platform engineering team. And with that, I will give the floor to Dr. Nolis and Chase. Thank you so much for joining us today.
I appreciate the intros, and we'll jump right in. We know we only have 30 minutes today for our session, so we certainly want to leave time for a couple question and answers at the end. So we'll jump right in. So with that, on the next slide, we actually have a link here to how you can follow along with a lot of the material today. At the beginning here, we're going to start with some background information. So feel free to go ahead and pull this up. And then as we start to get into a little bit more of the quick start and actual technical demo, you can start to follow along at the link that's on the screen now. All right. Give folks just a second to grab that.
And if you don't want to follow along and just listen to us talk, that is also acceptable. You will still get value out of this talk. So
absolutely. And then we'll have this link again as well at the end. So if you'd like to just listen and then do it, take it home for later, that's also great.
Yeah. And here we go.
Awesome. Yep. So we're going to start today's session by just doing a little bit of background on what is Snowflake. Snowflake is really a cloud data platform that we believe is one of the best platforms for machine learning today. It's what it's allowing organizations to do. It's allowing, a single platform to make all relevant data instantly accessible to data scientists. So this spans structured data, semi-structured data, and what we're going to be focusing about in this talk, unstructured data. This is a really powerful concept because, the idea that you can have that single platform to be able to access and query all of those different data types doesn't necessarily exist today. There's a lot of hybrid solutions. You may have to have different tools to work with all those different data types. We are really focused on accelerating. Oh, just one more slide.
Sorry, I got too excited.
No worries. So data processing for feature engineering or model inference, can be accelerated with Snowflake without any of the operational burden, regardless of the scale that you need to operate or the complexity of the number of concurrent users. We have fully managed intelligent infrastructure that doesn't require any tuning. So the days of going into tune the number of executors for your Spark cluster, that doesn't happen with Snowflake. We manage that all entirely for you. You simply just need to size the compute, correctly for your warehouse, and that can, of course, be a little bit of an iterative exercise. But you don't have to jump in and continue to tune it from there. We also provide tools in the developer, kit of choice. So if you want to use SQL, that's what a lot of our, Snowflake was really built around. Of course, we support that. Most recently, we've announced something called Snowpark, which is really our data frame API that we are exposing in Python, Java, and Scala for you to be able to manipulate data locally, but all the data stays within Snowflake, and you're able to do all that transformation using Snowflake Compute. And we can go to the next slide.
Great.
And again, so Snowflake is really that one single platform to access all those different data types. So if you think about this from a governance perspective in your organization, being able to have that single source of truth with one single governance pattern, you don't have to go and submit access requests to 13 different systems just to build your machine learning model because you need to pull in all these different data sources. That problem goes away. And it also integrates with all the existing tools and for your machine learning ecosystem. So today we're going to be showing that with Saturn Cloud, of course, but whatever your ML toolkit of choice is, I guarantee that we have a way that we can integrate with that. All right, next slide. And so, to that end, we have native connectors for Python, R, and Spark. So if you're running a Spark workload, you can use our Spark connector to connect, and Snowflake can be your data platform for your Spark workload. Again, you could use our new Snowpark libraries to be able to transform and manipulate your data. Our goal is to really simplify the MLOps process. So we want to make it really easy to expose machine learning models to your entire organization, or those that should have access at least. So what this looks like is you could actually deploy a machine learning model behind and create a function within Snowflake. So if somebody, like an analyst at your enterprise can go in and write a SQL query and call that function from within their SQL query that's actually calling a machine learning model or even a pipeline to that model to do transformation and then get a result back, really democratizing AI there. And of course, being able to do that within the confines of that one single managed platform, increasing trust, and a fully governed process for you. And we can go to the next slide. We truly do believe we're one of the fastest processing engines with the least amount of operational overhead. So we truly believe that we are the best engine for doing data pre-processing for your machine learning workloads. We'd love for you to put it to the test. Bring your workloads over. We'd love to do some benchmarking. But once you have the data in Snowflake, you're able to use tools like Snowpark, use tools like SQL to do all of your feature engineering, and then plug into your partner tool of choice for your training. And we can go to the next slide. And so what this looks like, and there's a couple of click-throughs, Jacqueline, sorry.
We did, yeah.
Yeah.
I'll put them all in. There we go.
Perfect. Thank you. The Saturn Cloud logo was the important one. So again, just to kind of put this whole picture together here of where Snowflake provides native capabilities for machine learning today, we are really focused on the data problem, right? We are not necessarily a native model training platform. That's what you're going to use a tool like Saturn Cloud for. But what we are is we really believe we're the best data platform, and that's where we see most of the headaches for the machine learning process coming in, right? The data management, the data ops piece of the machine learning process. So, we hope this sort of image helps put everything together, that you'll use Snowflake for all your data preparation. When you're ready to train your model, you plug into a partner. You could either deploy the model with that partner, such as Saturn Cloud or any, whatever other machine learning tool you may be using. You can deploy it there. You can also deploy it natively within Snowflake as well behind a UDF, as I was describing earlier, and you'll also use the ML platform for the monitoring piece. So again, just hoping to put all that together, and we can go to the next slide. And now I'm going to hand it over to Jacqueline.
Yeah. Okay. So given all that and all about Snowflake and storing data, now let's shift gears a little bit and talk about actual enterprise machine learning pipelines. So how do you actually do machine learning in an enterprise in prod? So when I think enterprise machine learning pipelines, and I think that all the time, I think about two totally different steps that kind of have to go on. The first step is your model training, right? You have some training data, you make a model training script that trains it in some way, and then you from there create a fitted model. And you'd be like, oh, that's 3 steps. That's pretty straightforward and obvious. But that's actually already fairly complicated, right? Because the training data often comes from many different places, right? Throughout your org. Some of the data might be structured, some of it might not be, some of it you have to use a SQL query to get, some of it you have to connect to an API. It's getting the data is complicated. And then, you have a fitted model, you make a training script, you fit a model, you may have to fit a model multiple times, right? You may once a quarter decide to retrain it manually. You may automatically retrain it, an automated once a day retraining, something like that. That can get fairly complicated. But even let's say you do have a fitted model, you then have your prediction steps where, okay, how are you going to actually use this model to provide value? Well, one thing you can do, and lots of enterprises do, is you have some sort of bulk inference process, right? So if you're a company with 70 million customers and you train a model to predict customer churn, whatever, you maybe once a month repredict all those 70 million customers. So you got to take that fitted model, you got to do a bulk prediction job of, hey, here's a massive amount of data, fit the model, have the model run correctly on that, and then get some results from there and save those results in a way that is actually useful to the company. So save them back to the database that stored the training data, one of the training data sets, or sorry, not training data sets, one of the inference bulk data sets. You could also just as easily imagine scenarios where customers have to do real-time predictions. So they have this spin-in model, and then the moment a customer shows up, they have to predict their churn. Right? After every order, the moment they do that, that could be via a REST API that you then use to host in a model like Flask, something like that. Or, as Chase was saying, you could like put into Snowflake these sort of systems where the moment a row is written into your database, it automatically fires these models. But these end up being fairly complicated. And they end up being even more complicated if your data is coming from a lot of different sources with like different ways of querying and different complexities, and especially with unstructured data, which like doesn't fit into your standard database model, which we're going to focus on especially today in this talk. So why are enterprise machine learning pipelines hard? Well, one, the data is often unstructured. It's complex, it's messy, it comes from a lot of places, and it may not just fit into your database. Two, you're probably going to connect to a lot of different things. Those connections need to be stable and secure, because if like, one of those connections goes down and you're trying to predict 70 million customers, and one of the databases your model needs suddenly isn't working, like that's really bad. Like these, and maybe if your models outputs don't exist, prod systems go down, your Netflix model doesn't make recommendations anymore, like that stuff's really bad. This stuff's important. And those models, they have to be quick. It can't take forever to run the models, because a lot of times these are real time, or if you have to predict 70 million customers, that's bad. And like I said, you may want to think carefully of how you do retraining, because your models will eventually get stale and you need to be ready for that. So that all adds a ton of complexity to enterprises in a way that like your standard side project may not have. So we're going to talk through one of these examples. And the example that I'm going to use here, presented by Snowflake and Saturn Cloud. I tried to make this look like an old-timey title screen. I don't know if that came across what I was going for. But the idea is, let's talk about an example enterprise pipeline and how they work through these problems with unstructured data. And let's do it by imagining a scenario where you have to classify images of garments. So you have some number of pictures of clothing. You want to classify them. That one's a dress. That's a shirt. That's a skirt. That's a shoe. I'm very good at this. You want to classify all of these, and you want to do it in a way that you can then save that data. But also these images, you probably can't just get them from a database, because images are generally unstructured data, right? They're not like a row column format generally. And this is like a good example. You can imagine that is one form of unstructured data. This could get far more unstructured, but like this is just a very nice, easy example. And this is like a real practical application. Nordstrom, Stitch Fix, lots of companies that have to do with retail clothing have to categorize that clothing, and they have to categorize images that maybe they get from customer reviews and things like that. So this is a real problem. So that's what we're going to set out to do. And so what would that look like as an enterprise pipeline? Well, here's one hypothetical example. So one, you could use something like Snowflake unstructured data sets to store that training data. You take those training images and you send them to a place where you train your model. In our case, because I work at Saturn Cloud, I'm going to use Saturn Cloud as the place I can run models. You could run models pretty much anywhere. So just for the sake of argument, let's say it's Saturn Cloud, but you're not limited to that in any way. Once you create your model, you then have some sort of, at some level, this is a mathematical function that takes this image and returns a classification of it. You store that in a useful place. And then you go into your predicting step, where in our case, let's say we have a massive, let's say we're doing the bulk version of this. So we have a massive unstructured data set of images stored in Snowflake, which I then have to pull into bulk. I have to store those very quickly. So I'm going to use Dask, which we'll get to what Dask is, to, in parallel, predict all these things at once, take the results and save them back to that Snowflake data set, so that it's very easy to look at both the image and what the prediction is. So quick aside, what is Saturn Cloud? Saturn Cloud is your data science environment. Basically, Saturn Cloud is a place where you can do machine learning data science. It's got built-in Jupyter labs. You can run notebooks on instances between, with GPUs or Dask clusters or 4 terabytes of RAM. You can run the stuff in production. We can schedule jobs and deployments, host dashboards and APIs. You can use admin tools to help manage a team so that you can easily transfer, you don't have a model that only works on your laptop and no one else can use it. And you can connect anywhere. So you can use Jupyter Lab built in, or you can use SSH and connect via VS Code or whatever. But the point is, this is a very nice, easy tool if you want to run machine learning models or train them. And I work there, so I like it. So that's the premise of what we're going to do. And I'm going to pass it back to Chase to just talk a little bit more about how we're going to actually store that data in an unstructured way, and then how it will then, flow back to the modeling side.
Yep, perfect. All right, next slide. Yeah, so again, using unstructured data, like what makes unstructured data special? It is typically very different than, firing up your SQL IDE and writing a query select star from, table, right? It is your unstructured data is typically sitting in object storage. It is folder or multiple folders full of files with very minimal, or no metadata. And most of the time, these services that you are storing your unstructured data in don't provide any sort of, layer over top to actually help you query that data or find it and retrieve it. So, Snowflake, our position in this space is to really bridge that gap. Where you're still using that underlying object storage, but we're providing the layer on top to make the management of it and integration with your other data sets much easier. Next slide. So again, unstructured data lives outside of Snowflake like S3. We can connect to that and provide our query engine directly over top to be able to integrate that with the rest of your data. So it's not just S3 if you're in Google. It's same thing, same object storage in Google, same thing in Azure. It's just using the major cloud providers, their underlying object storage. Next. So what does this look like? So the first thing you're going to do is you are going to create a stage, and you're going to, in this case, we're actually going to use an external stage. So that means you're managing the S3 bucket, and in this case we're at AWS, so you're managing the S3 bucket. Snowflake is not. So that means you have to give us the credit. You need to give us access to it. So one way is that you can give us AWS credentials to an IAM role, but we could also just establish an IAM trust relationship as well. And this is what allows us to authenticate with your bucket. Some of the data scientists in the room probably don't necessarily care that much, but your cloud architects and your security engineers that work at your company very much so care. And then you're going to run a very simple command just like this. And then next slide. And again, all of this is in the quick start and the link that we sent out. So don't worry about trying to capture this. It's all there for you. And then what you're going to do is you're actually going to set up a database. And so what this is going to do is point to the data that is still sitting in your S3 bucket, but we will parse all the information available about that data and log that metadata. And in here, for example, if we're going to do classification and we're going to create some predictions, we're going to go to create a table that will hold in a column that will hold that prediction for us, and we can insert a timestamp so that way, if we ever need to go back and update that prediction, we know when that prediction was updated. We also provide pre-signed URLs, and that's what you'll see of how you can actually retrieve that data from that underlying S3 object storage. All right, and back over to you, Jacqueline.
Great. Okay, so let's assume we've set those images up, those clothing garment images. They live in S3. Let's say we've set up a Snowflake unstructured data connection so that we can query Snowflake to get the images that are unstructured to use in our model. So we now need two things. One, we need a training notebook, right? Which will load the unstructured clothing from Snowflake. We'll train a PyTorch model, use a GPU, save the model. You could run this script by hand on a Jupyter server. Or you could set a schedule to automatically do this on newer, more recent training data periodically, whatever. But you need one training script. And then in our case, we need our bulk prediction script. So this is going to, again, load the data, unstructured data from Snowflake. And again, this is loading image data, but you can imagine for a full enterprise pipeline, it's probably loading in the images and when they were uploaded and blah, 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 and 8 things from 8 different data sets. And then we also have to load up the model file we created in step 1. Then in our case, because assume we're going to be training on, let's say millions of images at once, and we want to not be able to do that, not just have one machine doing that, we're going to use Dask to do it in parallel. Then we're going to take the results and save them back to the Snowflake database. And again, this could be run by hand if you want it for some reason. You could also set it to run on a schedule, or you could, either convert this to an API to actually just run one image at a time, or you can make an API that you hit every time you want the bulk inference to be done. There's a lot of ways you could actually deploy this. So if you want, again, just would like to lightly promote that you can use Saturn Cloud for free to do this. You get 30 hours of a 64 gigabyte instance and 3 hours of Dask a month, or you can get 16 gigabytes of RAM and a GPU. You got a lot of stuff there. So the point is we load the data in. And as Chase was saying, because the data isn't actually in Snowflake, it's in AWS S3, we aren't loading directly from Snowflake. What we are doing is we are getting from Snowflake a pre-signed URL. So that pre-signed URL is a secure way we can get that data from AWS. And you'll be like, why would I not just want to connect to AWS directly to get this data? Great question. Well, the reason why is if you can imagine in an enterprise setting, we don't want just every machine learning model having full access to an AWS S3 bucket and things like that. It's kind of like for a security perspective and just like data governance perspective, it's nice to kind of have Snowflake as the layer you use for doing your data accessing and usage, rather than sometimes pulling in Snowflake and sometimes pulling directly from AWS S3. So like this is a nice layer of a nice way to kind of lower the complexity and get everything from one place. So in our case, what we're going to use is we're going to use Snowflake to get those pre-signed URLs to tell us where to get the data from. And so in Python, we get the pre-signed URLs and then we just do a request to that URL. And then those quick URLs expire and such forth. So that's like a ephemeral artifact of this. And so then, okay, let's say we loaded that data in. So what are we going to do? In this case, it's an image classification model. So let's use convolutional neural networks. A super aside, a convolutional neural network is basically saying, okay, we're going to look at each pixel in the image and then look at the pixels around it and try and infer something from that. And then we're going to take those inferences and infer things from local groups of that. So you can kind of see here, you take one pixel, you look at an area of it, and you look at an area of those, and you look at an area of those, and eventually you get down to one output classification. There are many types of neural network layers. This is one of them that works particularly well for image recognition and text work. And so the point being, and each one of these layers is basically a whole bunch of linear regressions. So basically we are stringing a bunch of linear regressions together to take an image and turn it into a classification. We do this using PyTorch. We run this quickly on GPUs just so it's much faster to train. And so we do that, and let's suppose we create ourselves a classifier. But instead of cat and dog in this case, it will be telling us which of the classifications of images we want, shoe, dress, etc. So then let's say we train that model. Where do we save it? In the quick start, and just like for this hypothetical example, you can like just save it locally, like save it to a file and then upload that to S3 or whatever, just save it locally. But in an enterprise setting, you actually want to be much more thoughtful on where you save your models. You could save them to places like Snowflake. You could save them to other places. The issue with these models is it's actually quite complex to keep track of the models, because you really want to keep track of the versions of the models, right? When did you make the model? What data did you use to do it? Things like that. You want to keep track of what inputs went into the model, right? You can imagine, maybe 3 months in, you change it so that the images, instead of being square on input, they're now rectangles. Like you want to keep track of like how your model is actually expecting its input data, which changes over time. You also want to monitor the model performance. So if you keep saving models and the accuracy is getting lower and lower, you want to notice that. There's like 1,000 other things like this you really want to keep track of, which is all to say that saving a model feels like it should be the easiest step in the process, but I submit it as the hardest step in the process. This is a whole thing, right? There are companies, there are people who spend their whole careers, companies who are entirely invested to thinking about how to do this well. You should do that too if you're an enterprise, I would say. But that's not really the point of what we're going to talk about today. This is just an aside of like, please take this step seriously. So then let's say you train the model, and now let's talk about doing the actual bulk predictions. So again, you load up the data just like before from AWS through Snowflake, and then in our case, we're doing Saturn Cloud, but wherever you're going to want your model to run. And then in our case, we're going to use Dask. Dask is a really cool, powerful open source tool that can entirely in Python do things in parallel in a distributed cluster. And so in our case, we're going to have Saturn Cloud like running a Jupyter server that's using Dask client, and then farming that out to a cluster of Dask workers so you can do your complex thing in parallel, and your inference will run much faster. This is great. Dask is built into Saturn Cloud. Again, there are other places you can run it, but it's a really nice tool if you're like, I want to run something that's really slow really quickly. Dask, and I don't want to go through the effort of setting up a Spark cluster and stuff. Like Dask is a really nice way to do it. And then lastly, we then once we have the predictions, we can then update the data in Snowflake. So at its core, that unstructured data is still a table with the pre-signed URLs and things like that. And we can just add the columns for the inferences and like what the confidence was and things like that. We're going to save that back in just like it was SQL. So it's nice to save your results right to where the input is. And so just you use an update query in Python to do that. So that's kind of the gist. The takeaways here is that that's kind of what an enterprise pipeline looks like. You can use the unstructured file storage stuff of Snowflake to let you really nicely, which, those new features to get that nice level of control and security when you're doing, loading in like files from AWS or unstructured stuff that won't fit in a database. And you can use Saturn Cloud if you want to do the machine learning stuff of that, although you can do that anywhere too. It's just a nice way to access that. And once you have that model that you've made, you can run it and then save those results back to Snowflake, and you get a nice like loop of take your data, run your model, put it back, take your data, run your model, put it back. And that can be a really powerful tool. So with that, thank you so much. I want to make sure I got a little fast at the end because I really want to leave time for question. But as stated at the beginning, you can get our code is available at SCLD, that's short for SaturnCloud.io, scld.io/Snowflake Quick Start, or PyData 2021 Snowflake for the actual slides you're looking at right now.
Our time with you is over. Thank you so much, Jacqueline and Chase, for your talk and for being part of PyData Globo 2021.
Thank you.
Awesome. Thanks, everyone.